Hello friends, I am Sneh Bansal. Today we will perform an experiment to test the pH of different solutions. First, let me give you a brief introduction about what is pH paper and what is litmus paper. pH is a negative logarithm of the hydrogen ion concentration, that is pH is equal to negative log of hydrogen ion concentration of any solution. From this mathematical equation we can deduce hydrogen ion concentration of any solution is inversely proportional to its pH. That is, if hydrogen ion concentration of any solution is low, then its pH would be high. If hydrogen ion concentration of any solution is high, its pH would be low. Next is litmus paper. Litmus paper is a natural indicator of pH. It is of two colors, blue litmus paper and red litmus paper. pH paper is a strip of paper that is made up of natural indicators and then it is dried. This pH paper is used to know the pH of any solution. Now let us proceed with the experiment. In this experiment we will use these materials. I will use this glass rod to put the solution onto my litmus paper. Here are 5 solutions and a distilled water, dilute hydrochloric acid, dilute acetic acid, dilute sodium hydroxide, dilute sodium bicarbonate or dilute sodium hydrogen carbonate, dilute sodium chloride, distilled water, red litmus paper and blue litmus paper and pH paper, blotting paper. I have used a white tile to keep my strips of pH paper and litmus paper over it. Why I have used a dried and clean white tile? Because with the background of white color, my color on the litmus paper is completely and clearly visible. Now let us start with the experiment. First put glass rod into the water and rinse it and clean it with blotting paper. This is required so that there is no mixing of solutions. Then I kept my glass rod into dilute hydrochloric acid and put one drop on blue litmus paper. We can use forceps to hold this litmus paper. I will take another drop of dilute hydrochloric acid and put it on red litmus paper. We have to wait till it get dried and then we can see the color is changing. Blue litmus paper is turned into red and there is no change on red litmus paper. Rinse it again in water and then dry it with blotting paper so that there is no mixing of solution. Then take dilute acetic acid and put a drop on another blue strip of litmus paper and a drop on red litmus paper. And the change you can see that here also the blue litmus paper is changed into red and there is no change in red litmus paper. Again we will rinse it and dry it. Now dilute sodium hydroxide. Put one drop on blue litmus paper and another on red litmus paper. And here you can see that blue litmus paper has no change whereas red litmus paper is changed into blue. Again we will rinse it and dry it. Now it's sodium bicarbonate. One drop on blue litmus paper and one on red litmus paper. Here also blue litmus paper remains same whereas red litmus paper is changed into blue color. Again we will rinse it and dry it. Now sodium chloride. One drop of sodium chloride on blue litmus paper and one drop on red litmus paper. Here the result is different. There is no change on blue litmus paper and there is no change on red litmus paper too. Now distilled water. One drop of distilled water on blue litmus paper and 1 drop of water on red litmus paper. Here also there is no change in color, neither in blue litmus paper nor in red litmus paper. Now we can see that dilute hydrochloric acid and dilute acetic acid has changed blue litmus paper into red, representing that they are acids, whereas sodium hydroxide and sodium bicarbonate has changed red litmus paper into blue. That means they are base. And sodium chloride and distilled water, they have not changed neither in red litmus paper nor in blue litmus paper, representing that they are neutral, they are neither acidic nor basic. We will repeat the same procedure with our pH strips. Now I will take one strip of pH paper and I will dip it into the respective solution, and I have a pH chart here, and then we will match the color change with this pH chart and we will see whether it is a strong acid, weak acid, strong base or weak base. First of all, we are doing it with dilute hydrochloric acid. As you can see, the orange color is changed into pink, and we will match it with our pH chart. The pH chart says it is 2. That means the pH of hydrochloric acid is 2, meaning it is a very strong acid. Next, repeat the same procedure with acetic acid. Here the pink color is slightly light, not as dark as it was in hydrochloric acid. The shade is light, representing it is also an acid but not as strong as hydrochloric acid. Now with sodium hydroxide, color is different, it is of blue color. If we will match it with our pH chart, the pH says it's 10 or 10.5, that means it's a very strong base. Dilute sodium bicarbonate has also changed into blue, but it is not that dark blue as it was in sodium hydroxide. The color is 9, that means pH is 9 and it's a base. Now with sodium chloride, you can see there is hardly any change, and if we will compare it with our pH chart, the pH is near 6, it's 6 or 6.5, representing it's a neutral solution. Now with distilled water, here also there is hardly any change in color, it's also a neutral solution, it's neither an acid nor a base. So friends, as you have seen that dilute hydrochloric acid and dilute acetic acid are acids, dilute sodium hydroxide and dilute sodium bicarbonate are bases, dilute sodium chloride and distilled water are neutral solutions. So we have inferred with today's experiment that acetic acid and hydrochloric acid has changed blue litmus paper into red color, representing that they are acids. So sodium hydroxide and sodium bicarbonate has changed red litmus paper into blue, representing that they are bases, whereas sodium chloride and distilled water, they have hardly changed their color, representing that they are neither base nor acid. We have also tested their pH by dipping the strip of pH paper into the respective solution and observed the color change with our pH chart. Now we can infer that some solutions are highly acidic, some are moderately acidic, some are highly basic, some are moderately basic, and some are neutral. Suppose you don't have litmus paper or pH paper in your school, then how would you conduct this experiment? That will show you in our next experiment.